All right. So, second, I got to click on the got it. Okay, so we are doing sections 3.4 and 3.5 today, and then we will look at lab number 2. Since we're just using the same data from lab number 1, your continuous data, lab number 2 goes fairly quickly. Excel does all of the work for you, and I love it when Excel does all the work for me. And that's kind of the point of Excel, is so that it does all the heavy lifting, and you just learn how to type in the easy commands to get it to do what you want it to do. And I'm sure some of you have had CS 120, so might have a little bit of Excel experience, but even so, I know we don't always remember things. If you don't use it, you lose it. So I'm hoping to teach you some useful things today. So section 3.4, we're going to learn about something called z-scores. Then we're going to learn about something called quartiles, and we're going to determine figure out what they are, how to find them, what they mean. And then we're going to talk about something called interquartile range, which, if you were thinking, it sounds a little bit like quartiles, though they're related, so it makes sense. I talk about outliers, which are unusual values. We're going to talk about those. And then section 3.5 is really mostly about box plots. And I can tell you that 99% chance that you'll have to draw a box plot for your first test. So take good notes, copy things down, the one I do, and follow along. And hopefully box plot will come easy for you. We're going to do lab 2, as I said, super fast and easy. It will not take very long at all. So this is today's stuff, and pretty much everything we learned today is fairly important. All of the stuff with median, like quartiles, interquartile range, 5-number summary, and box plots, those aren't things we carry with us too much to the rest of the course, but they are important things on their own. But the z-scores is something that we're going to keep revisiting over and over and over and over again. So z-scores are pretty important. All right, let's move on. Maybe. Okay. So a z-score tells us how far a data value is from the mean. So standard deviation, it tells us how spread out our data is. So standard deviation is kind of like our unit of measure. A z-score will tell you how many standard deviations something is from the mean. So if we look at our bell curve, the mean would just be 0 because that's the mean. Then when I add one standard deviation, so this is the mean plus a sigma, this z-score would just be 1 because I am one standard deviation above the mean. Down here, mean minus sigma, this is 1 below the mean, so my z-score would be -1. So this is essentially what z-scores are doing. They're telling you how far are you away from the mean. And we can use these z-scores also to determine if something is an outlier. And I'll talk about that in a few minutes. And there's also this supplemental video that I posted, and it's probably something that you should watch. It digs into outliers a little bit more. It's called Outliers and Data Analysis Tool, I believe. So it's worth a watch, at least the outlier part for sure, because I'm going to go over the data analysis tool in this class tonight. All right. So to find the z-score, you take your data value, you subtract the mean from the data value, and then you divide it by the standard deviation. Both of these things are actually the same. Oops. Why did I not fix this? Don't put mu there. Change this to sigma. Change that to sigma. Sorry, it was a typo. So you take the data value minus the mean and divide by sigma. Both of these formulas are the same thing. This is just with the sample. So I use different, we use different symbols, because remember the sample mean is X bar, sample standard deviation is S. So it's the same formula. You're just using different symbols. But the z-score is supposed to say, the z-score does not have units. It does not have units. So you don't say it's 1.5 pineapples, it is just 1.5 is your z-score. So there's no units there. All right, moving on. Let's calculate some z-scores. So the mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7 inches. This data is based on National Health and Examination Survey. So we're looking for who is relatively taller. So what we mean by relatively taller is if I'm comparing Kevin Garnett and Candace Parker, obviously Kevin Garnett is taller, but you're looking at, so the means are different and the standard deviation is different. So we're saying, you know, if we compared their height to the mean height, which one is relatively taller? So when we get them in the same units, so putting it in z-scores is, instead of comparing apples and oranges, we will be comparing strawberries and strawberries. So you're actually comparing two like things once you put it in z-scores. So I'm going to find these two z-scores, and once I compare those two z-scores, then I'll be able to tell who's relatively taller. So let's take a look here. So I take 83, which is the data value, subtract the mean, which is 69.1, and then divide by the standard deviation, which is 2.8. Now, if you put this whole thing in your calculator all at once, make sure that you put parentheses around your numerator. Otherwise, you will get the wrong answer. So you put parentheses around the numerator, like this, and then divide by the denominator, divide by the standard deviation. So the z-score for Kevin Garnett, 4.96. Man, that's big. So keep in mind that any z-score higher than 2 or any value more than 2 standard deviations away from the mean is an outlier. So 4.96 is majorly an outlier. That's crazy. All right, let's look at Candace Parker. So we take her actual value. So 76 minus standard deviation, or sorry, mean of 63.7 divided by 2.7. Boy, that's ugly writing. Sorry about that. Make sure you're using parentheses again. All right, so that her z-score is about, whoops, apparently I can't write, 4.56. So while her value, her z-score is still an outlier, because remember, anything more than 2 standard deviations away from the mean is an outlier. Even though hers is still an outlier, it's not as big as Kevin Garnett. So relatively, Kevin Garnett is taller because he is further away from the mean, more standard deviations away from the mean than Candace Parker is. So he wins. Questions on that? Okay, I do have another example. All right. So we're going to determine whether the Los Angeles Angels or the Colorado Rockies have a relatively better run producing season. So the Angels scored 733 runs and play in the American League. The mean 677.4 and the standard deviation is 51.7. The Rockies scored 755 runs. They're in the National League where the mean is 640 and the standard deviation is 55.9. We want to know which team had the relatively better season. So compute those z-scores. I'm going to write that z-score formula for you again. And then I would like you to try this. I'm going to work quietly in the background. So if you get stuck, go ahead and look up, but go ahead and try this on your own. Give y'all another moment or two. We'll talk about this. All right. How'd we do? I got a z-score of 1.85. Well, you did good?
I did good.
Yay! All right, so for Angels, I got a z-score of 1.85. For Rockies, 2.06. The Angels are not an outlier. They still had a really good season. They're not an outlier. Rockies are an outlier, barely an outlier, but they are, because remember, any z-score more than 2 is an outlier. The Rockies did relatively better, even though they had fewer runs. Based on that mean and standard deviation, they had a better season. Questions? All right, we'll move on. So we're going to shift to quartiles. Now that we saw z-scores, I'm going to one more time reiterate, because this seems to be a sticking point for a lot of people. One more time, I'm going to my other screen. It's supposed to go black. I'm going to draw the bell curve. So this is my mean. This is mean minus 1 standard deviation. This is the mean plus 1 standard deviation. This is the mean minus 2 standard deviations. And this is the mean plus 2 standard deviations. So as we know, 95% of our data lies within 2 standard deviations of the mean. So everything in here is 95% of your data. Anything outside of that 95% is an outlier. So anything more than 2 standard deviations away from the mean, I'm going to write this down. Anything more than 2 standard deviations from the mean is an outlier. So anything outside of that 95% is an outlier. Yes, when we draw our bell curve with the empirical rule, we include the 3 standard deviations, but still outliers are anything more than 2. So 95% of our data, that 95% part is where all of your usual values. So anything else is considered an outlier or unusual. Just wanted to make sure to point that out, because it seems to be a sticking point because of the way we draw the bell curve. It seems to be a sticking point every term. All right.
Yeah, I thought it was in the point, whatever, 15% that's on the outside.
Yep.
So I'm glad that you clarified that.
Yeah, and it's like half the class every term. So that's why it's not just you. So don't think that, oh my gosh, I can't believe I didn't get that. It's really, really common. So it's normal for people, because of the way we draw the thing, and we think, okay, if 99.7% of our data is here, that must be where all the usual values are. But it's that 95%. It's basically because in stats, anything with less than a 5% chance of happening is considered unusual. And so that's why it's the 95%. Because anything less than 5% chance of happening is considered unusual. So anything outside of 2 standard deviations. So if I had a z-score of 2.01, that's an outlier. Or a z-score of negative 2.03, that's an outlier. So anything bigger than 2 or smaller than negative 2 is an outlier on the z-scores. All right. Hope that helped. That's actually why I made that other video, the outliers and data analysis tool. I specifically made that video because of this issue, but it's just a thing. And I don't know. It's a common error. It's okay. Hopefully we caught a couple of these before it becomes a problem. All right, let's move on. Let's talk about quartiles. So we're going to jump back to median. So, we use median a lot when things are skewed. We use it when they're out, we know there's outliers present, like that are visible outliers. We use quartiles only with median. I'm just going to write that here, only with median. So if we are using median for our center, we will use quartiles. We use this instead of using mean and standard deviation. We deal with quartiles. So the way that way we get quartiles is we're going to divide our set into 4 equal parts, our data set. So the first quartile is our bottom 25% of our data. We write it as Q1 like this. And it is the point at the first quartile is the 25th percentile of the whole data. The second quartile is the median. We almost never say second quartile or Q2. We just call it the median. It's the 50% mark. It is that middle number. And this is a whole lot of words saying something super simple. Third quartile, it's at the 75% mark. So it splits the top 25% from the bottom 75%. So the third quartile would be the 75th percentile of your data. And so we just divide our data into 4 pieces, and we're going to do some examples. So no worries. And we're going to jump back to the calculator and use one variable statistics. And I'll show you all the cool stuff we can do with quartiles with that. It's not super cool, but it's better than doing the math. Because I really don't want a data set of 50 values and then have to put them in order from smallest to largest. That doesn't sound fun at all. All right. So here's a great visual. If nothing else, this right here is a great visual to put in your notes. This little diagram right here. If you don't print out the PowerPoints ahead of time, this is a really great thing to draw in your notes because it does a pretty good job illustrating it. It's better than the words, if you ask me. So if you don't have the PowerPoint printed out, go ahead and draw this and I'll give you a moment. Anyone need another moment? Can I move on? We're good? All right. Here's how we find our quartiles. And once again, it is a lot of words. First thing you want to do, arrange your data in ascending order, smallest to largest. Second step, find your median. You know how to do that? We've got some practice there. Next. So what you're going to do is you're going to basically find the median of the bottom 50%, and that'll be Q1. And then you find the median of the top 50%, and that'll be Q3. And it's going to make much more sense once we do it. You're just finding the center of the bottom part below your median and the center of the top part above your median. And that'll be a
quick question.
Okay.
Is there a way to input the data into the calculator and have the calculator later arrange it?
Well, it won't arrange it for you, but it'll find your quartiles for you. And we're going to do that in a minute. Excel, however, will arrange it for you. So you could always use Excel.
I did that question in homework, and I did it about 5 times before I got all the answers correct because I would just miss it by one little mistake. And I'm like, oh, I'll go back and fix that mistake. But I did it all by hand. Oh, and then when I was done, I remembered that the calculator will tell me the Q1 and the Q3.
It will.
But it took me hours.
Oh, no. Well, you did the homework before the class?
I did. I watched all the videos. That's how I do it. I'll watch the videos, I'll do the homework, and then I'll sit through class so that if I have any questions, and then I feel like I'm retaining more. Oh,
I see no problem with it. I've had a lot of students do that, and have been some of my best students. So good job. Good job. I know it's more time consuming that way, but if you get it, that's great. If it helps. All right, so let's actually do this. So I already arranged these in orders from smallest to largest because we know how bad I am at doing that. You guys haven't experienced it yet, but I'm really bad at that. So what this is somebody collected the speed of vehicles traveling through a construction zone on a state highway. The posted speed is 25. And so here are 14 randomly selected vehicles. And notice how they're almost all above 25. So rude. So we're going to find our quartiles. So we all know how to find the median. And since this is 14 data values, there'll be 7 below my median and 7 above. So 1, 2, 3, 4, 5, 6, 7. So my median is right here. And this would be 32.5 would be my median. Because 32 plus 33 divided by 2 is 32.5. So that's my median. I'm just going to write MED right there. And now we're going to find the median of the top. We're going to find our Q1 and Q2, or Q1 and Q3. So there are 7 values below the median. We need to find that center value. So the 7 values below the median, the 4th one will be our center value. So this right here is our Q1. And same thing with the top. There are 7 values above my median. So the center value will be my Q3. 1, 2, 3, 4. So right there, there's my Q3. So now we have our Q1 and our median and our Q3. There's 20.
Quick
Okay, go ahead.
question, sorry.
No, it's okay.
What if you had a positive number, like in trying to find your Q1 or Q3?
Need an even number.
Oh yeah, an even number, excuse me,
Same
in the
thing.
amount.
Yeah,
Would you
could-
just do the same thing that you did to find the median?
Yes, you do this,
Okay,
add them together and divide by 2.
okay.
Yeah. Good question. Good question. But this is 25% of my data. This is 25% of my data. This is 25%. And this is 25%. We just split it into 4 pieces. And that's it. That was the interpretation part, that 25%. And this seems like it doesn't have a purpose, but once we're calculating the interquartile range, you will see there's purpose here, and it's going to help us find outliers and all of that. So there we go. I'm going to move on. Okay. This is exactly what I just wrote. This is a whole lot of words to say what I just wrote below. 25% of our speeds are less than or equal to the first quartile of 28 miles per hour, and 75% or greater. Half of our speeds are less than or equal to the second quartile or the median of 32.5. 75% of our speeds are less than or equal to the third quartile of 38 miles per hour, and 25% or greater. That's all it is. This doesn't seem super useful yet, but it will. All right, we're going to practice. So here's the highway loss data. I put these in order for you. I don't think the PowerPoint that you uploaded or that you downloaded has them in order, because I don't think I updated that yet. But I put these in order. I just did it last term because it was really annoying me trying to do it while class was happening. So there are 18 collision coverage claims based on data from the Highway Loss Data Institute. So go ahead and see if you can find, actually, let's do it on the calculator. That's a great idea. I'm going to show you the calculator. That's a great idea. All right. Maybe. Here's my TI-84. So as we learned before, you click on stat and then we edit. And I already have numbers in here, so I'm going to highlight my L1 and clear. Then I'm just going to enter these values in here. Feel free to enter them along with me.
We can't see the values anymore.
That's why I said you can enter them along with me. I'll make this bigger.
Oh, perfect.
I'll make it bigger. That's what I'm saying. Now hopefully you can see them. Can you all see them now? I can make it even bigger if you need me to. Let's see if I can do this without typos. My most common error is making typos while I'm typing things in the calculator. If I get something wrong, working on a computer, if I get something wrong, the first thing I do is go back and see if I entered the numbers incorrectly. Okay, I'll give you all a second to finish getting those in there. So this I was looking at the 21,147 on there. The first time I taught this, I was like, man, that seems like a lot for a collision. And then the same day school shut down in 2020, I hit a deer on my way to work. It was just a bad day all around. And my car had $18,000 worth of damage from hitting that deer. I even tried to find the deer because the laws changed now that you can actually, if you hit a deer, you can take the meat home, take it home and keep the meat. I was going to give it to my sons. Could not find the deer. I also could not find the Volkswagen emblem to the front of my car. All right. Does anyone need another moment? Or are we good? Okay. So as we did before, we're going to use our one variable statistics. So hit stat, arrow over to calc, and we want the first choice, one variable statistics. My data was in L1. So I'm going to keep that. Frequency list is nothing and hit calculate. So this is a familiar screen. We have our mean, we have our standard deviation. We don't care about all that. What we care about is right down here. So our Q1 right here is 735. Our median is 1805 and our Q3 is 4668. This definitely helps us because now having this here, you don't have to put them in order because putting them in order is the hardest part. Yes, you can type them in Excel and you can have Excel order them for you, but this is faster. And it gives us, huh?
Oh, somehow I got 3,461 for Q3. And my
Okay.
Q1 is the same. I must have entered something in.
Yeah, it must
wrong.
have been one of your later. Here, I'll go back down and it would have been one of your later values, maybe.
Yeah.
Here. There we go. I'll give you a second to look at those and try it again.
Okay, thanks.
I cannot believe I spent so much time rearranging all of those numbers. And then when I was with the last attempt, I was like, oh my goodness, my calculator will tell me what Q1 and Q3 is. I don't have to do this. Yeah.
Sorry, I'm almost done.
Oh, it's fine. I want to make sure that you can get the answer. It's important.
I do make a lot of calculator errors though, so I'm glad that I know how to find the answer on paper.
Yes.
Um,
And I always
I-
think about reasonableness because sometimes I get an answer and I'm like, that doesn't look like it's the right answer. And so I have to check myself because, they talk about, we don't need to know how to do math because we have calculators, but you need to be able to look at the answer you get and determine, is that reasonable based on what I know about this math? And your calculator can't tell you if it's reasonable. It's just going to give you an answer. Did you find your error?
I did. Thank you.
Okay. So I'm going to go back to that screen so you can make sure that you have the same answer. And there we go. Yes?
Yes, got it. Thank you.
Okay. All right. Okay, good. We've got our Q1 and our Q3, so we're good. and I'm going to go to the next screen, I think. So now we're going to talk about interquartile range. So interquartile range is median's answer to standard deviation. So it is the center 50% of your data. So you just take Q3 and you subtract Q1 from Q3, and it will give you your IQR, interquartile range. So here's the speed data. Okay, I'm going to give that back to you just a second. Okay, here's the speed data. So my Q3 was 38 and my Q1 was 28. So would you just do 38 minus 28 and you get 10. So this right here is my IQR. It is the interquartile range, and it is okay to just refer to it as IQR. It's what everybody calls it. We don't say interquartile range a lot. It's kind of a mouthful. It is a really easy word to mess up when you say it. So it's really that simple. So so it is the middle 50% of our data. So our middle 50% is 10 miles per hour. So let's take a look. Oh, I was going to talk about the volatility of standard deviation and mean. But our interquartile range for our insurance data, we would just take 4668, subtract 735, and this will give us our IQR. So our IQR there on the highway loss data is 3933. So that is our interquartile range. That's our middle 50%. It kind of helps us to see how spread out our data is. So that, along with the actual data range, it helps. Mostly what we use IQR for, though, is for outliers. So we're going to get there in a minute. Right. So suppose we had another car travel through the construction zone at 100 miles per hour. Let's take a look at how it impacts the mean, median, standard deviation, and interquartile range. So kind of showing you how the mean and the standard deviation can be drastically changed by one extreme value. So take a look at the mean. Our regular mean was 32.1. Once we had that 15th car, it was pulled up to 36.7. That doesn't seem extremely outrageous, but look at the standard deviation. It went from 6.2 to 18.5. That is a huge difference. Whereas on the median, our median was 32.5. It just went up to 33. It barely moved. Our IQR went from 10 to 11. So it also barely moved. So when we have outliers, we have some extreme values, we tend to use the median and the IQR rather than the mean and the standard deviation. But remember, these two things are connected, and these two things are connected. We don't use IQR with mean, and we don't use standard deviation with median. They are separate things that we don't use together. So if your data is symmetric, if it's bell-shaped, or as they call it, normal, we would use mean and standard deviation. If it is skewed right or skewed left, you're going to use your interquartile range and your median. This is just a general rule of thumb, but I'm pretty much going to tell you what to use. You just might be asked, which one should I use? That's how you determine. All right. Questions? Are we good? All right, moving on. Checking for outliers using quartiles. Okay, so before I do this, I'm going to once again talk about standard deviation because it is not included in here. But for example, let's go back to this data right here, 6.2 standard deviation and 32.1 mean. So my mean is 32.1 and then standard deviation is 6.2. If I was looking for outliers using mean and standard deviation, you would take your mean and you would add 2 times the standard deviation, and this is going to give you your upper bound. Which would be 44.5. So any value higher than 44.5 would be an outlier. This is my upper bound. That would be my z-score of 2. My lower bound would be 32.1 minus 2 times 6.2. And that is 19.7. So anything lower than 19.7 would be considered an outlier. It would have a z-score of less than -2. So I just wanted to bring that point home. This is also, I talk about it quite a bit in that supplemental video. But if you've got it, if you understand this, because it'll say, you'll have problems in this section that says, use the 2 standard deviation rule to find the upper and lower bound, or use the one, you'll see the other way in a second. So this is the 2 standard deviation rule right here. All right. Questions before I move on? Okay, moving on. So checking for outliers. Find your first and third quartiles of the data and compute the interquartile range. So we call the upper and lower cutoffs, or the upper and lower bounds, we call them fences. Call them upper and lower fences. I don't know why, it just is what it is. So you take quartile 1 minus 1.5 times the IQR. This will give you your lower fence. Any data lower than your lower fence will be an outlier. For your upper fence, you take Q3 and you add 1.5 times the IQR. This gives you your upper fence. Any data value higher than that upper fence is an outlier. I think that's what this says. It does. Give you a second to write down what you need. Okay, anyone need another moment? Are we good? Okay. Let's use our speed data. So remember that our first quartile was 28 and our third quartile was 38. So our interquartile range was 10. So I took Q1 minus 1.5 IQR. So I took 28 minus 1.5 times 10, and I got 13. This is my lower fence. So I took my Q1, subtracted 1.5 times my IQR, 13 miles per hour. Took 38, which is Q3. I added 1.5 times 10 and got 53. Any value higher than this would be an outlier. So these are my upper and my lower fences. Any values beyond those are outliers. And I don't think we had any outliers. Yeah, it says there weren't. So you just go back to the data and take a look at it and say, are there any outliers? Nope, there's nothing greater than 53 or lower than 13 because we excluded that 100-mile-per-hour car. There was nothing greater than 53 or lower than 13, so there are no outliers, so we're good. We're going to do this again with the highway loss data, and I'm actually going to calculate it out. I don't know about you guys, but I tend to follow things more if the instructor is writing it out and talking through it, rather than having it printed on the screen. The reason I do it both ways is for people who print it out and maybe they don't trust their own notes, or if they don't actually watch the video, so that there's actual examples there. That's why I do it both ways. So let's take a look at the collision loss data. So my Q1 is, I have it written down, 735. And my Q3 is 4668. I'm pretty sure that I still have my, so my IQR we determined is 3933. Okay, so I'm going to do my lower fence. So my lower fence, you take 735, which is Q1, and I'm going to subtract 1.5 times the IQR. So 735 minus 1.5 times 33. So this is clearly, we do not have any values lower than this, obviously, because we have a negative number, and that's okay. It happens. But I don't think anybody is owed. Maybe they improved their vehicle. Though I've seen some vehicles that I feel like they might be improved if somebody ran into them. But you've all seen them too, haven't you? Our upper fence is, so it's the quartile 3, so 4668 plus 1.5 times 3933. I'm gonna 4668 plus 1.5 3933. It is 10,567.5. We happen to have a value that is $21,147. So we have an outlier. Because this value is higher than our upper fence, this value is an outlier. Questions? Pretty straightforward. Does anyone need another moment, or can we move on? All righty. Going once, going twice. Moving on. Okay, I believe right now is when we were entering into 3.4, unless it was before. I believe this is the moment we're entering into 3.4. If you keep track of that sort of thing, I think the reason I didn't label it is because 3.3 and 3.4 are one assignment, or 3.4, 3.5. Lied to you. So whichever one we're on. What chapters are we on? Is it 3.4 and 3.5? I don't know where we are.
Yes, you did. Yeah, it is.
Okay, so we just entered in 3.5. I'm sorry. I'm like, I don't know where we are. The last one. We're on the last one. All right. We're almost there. We're doing good. We're drawing the box plot is going to be a little bit time consuming, but I think the fact that I'm going to draw one out and you're going to draw it with me is going to be helpful, but we're almost there. Y'all are doing fantastic. Okay. So the 5-number summary, basically, you take this big long data set that we have, and we just take the 5 most important numbers, 5 most meaningful numbers, and we just kind of list them out, because those are the only numbers we really need from this data set. So rather than writing down all of the numbers all of the time, we just write down the most important of them. And you don't even have to label them. You just put them in this order. You write the minimum number, quartile 1, median, quartile 3, and then the maximum. You just put those numbers down. If we know that it's a 5-number summary, you know what those are because they are written in order. So this is the 5-number summary. Remember, 5-number summary is not all the data. It is just those pieces.
Are those just the minimal and maximum in the calculator? Sorry, it's been a long day.
Yes, they are.
So, okay.
Given a 5-number summary in your calculator. I think I still have it up here. So my 5-number summary is this 180, 735, 1805, 4668, and 21147. These last 5 things right here are the 5-number summary. So, I mean, and now I just told you that, and we're going to go to the screen that says, hey, give the 5-number summary of the collision loss data. And there it is right there. But you do not have to label them. Obviously, the calculator has to label them, but you do not have to. You would just write 180, 735, 1805, 4668, 21147. You would just write them out, and you would call it a 5-number summary. And it's kind of nice because you don't need every data value. This is all you need. This is the important pieces. Do you need a second or can I move on? Can I swipe away? Be good. All right. All right. So let's take a look at the 5-number summary of the speed data. So I'm actually going to have to go back here. Is it in my calculator? It's not. Okay. So let's hold on a second here and I will.
I
don't-
wrote them down if you want.
You did?
Mm-hmm.
That's why I keep you around. So what is the minimum value of the speed data? What the heck happened here? What is the value?
Minimum is 20,
Okay. And my Q1?
28,
28. Median.
32.5,
Okay. A Q3
38
and maximum.
is 40.
Thank you so much. That's
You're
it.
welcome.
That's all. Right. Just like that. So we've got our 5-number summary. Seems way too simple. I know. So let's look at the collision loss data. I have it right here, so I don't have to. So our collision, we already did this. I mean, I showed you that screen. So our collision loss data, you would do 180, 735, 1805, 4668, and 21,147. There you go. Now I need to warn you, there is a problem in your assignment. It trips people up every single time. They give you the 5-number summary and then they ask questions based on it. So you need to make sure you don't treat it as a data set, that you treat it like the 5-number summary. So make sure you're reading the instructions, because so many people will try to find the Q1 and Q3 and median, and they all sorts of crazy stuff happens. Because if I was on this 5-number summary, median is still median, but then my Q1 would be in here somewhere and my Q3 would be here, and it's going to mess everything up. But that's not the case. If they give you the 5-number summary, you know that this is your Q3 and this is your Q1. So make sure you just pay attention to whether they gave you a data set or the 5-number summary. It's just a real common error, so I wanted to make sure to bring it up. Okay.
You have grown a lot since your videos.
Thank you. It's because now I've been teaching this a while. I think that when I made those videos, it was only my 3rd time teaching this class. And so I've taught it a lot of times since then, like every term, including summer since then. And I've been the beginning one. So I think chapter 1 and chapter 2, I have redone, I've re-recorded, but I'm trying to work my way through the rest. They're just really time consuming because I make a lot of errors and have to start over. And so that's why I encourage people to watch the Zoom, because I keep saying I'm a much better teacher now than I was when I did those videos. So thank you. I take that as a compliment for sure. All right, let us move on. Drawing a box plot. All right, so pay attention. I think that the instructions are not super helpful, but the actual drawing of it is what's going to help you. I am going to give you the instructions though, because it's what we do. Maybe. Okay. Number 1, find your upper and lower fences. So you know how to do that with the 1.5 IQR rule. So find those upper and lower fences. Well, and it tells it right here also. And I don't want to drive anyone nuts with this random blue line there, so I'll erase it. Step 2, draw a number line. Now listen, the number line that you draw is just a standard number line. You're not just labeling the points on your graph. You're not just labeling your 5-number summary. It's just a standard number line. But you're going to have to determine where it starts and ends and what your scale is going to be. But it's just a standard number line. And it's going to be underneath your box and whisker plot. But you're going to have to put vertical lines at Q1, median, and Q3. And those are going to create a box. Then you're gonna label your lower and upper fences. Oops. And all these steps sound well and good, but once I draw it, it's gonna make much more sense. This is more for if you printed out the PowerPoint and you're going back to look for directions. But the drawing it out is where you're gonna get some help. Then you're gonna draw a line from Q1 to the smallest data value that is larger than your lower fence. The line doesn't go all the way to your lower fence. It goes to the smallest data value that's still inside your fence. The other one is in the largest data value that is smaller than your fence. So it just goes inside your fence. It does not touch your fence unless your fence is that largest data value. So it just goes to the largest data value that's still inside the fence. These are called the whiskers. These lines are your whiskers. The last piece, if you have any outlier, you're going to mark it with an asterisk. You're going to put an asterisk where your outlier is. These are
I'm
all.
sorry, could
Go ahead.
you explain number 4 again?
So if I have,
Yeah.
like, I have this box and whisker plot, this is going to be a really ugly one. This is my fence and this is my fence. So let's say that I have an outlier out here, but the last data value that is not an outlier is right here. This is as far as my whisker is going to go. I'm not going to draw it all the way to the fence. It just goes to the last data value that's still inside the fence.
Okay, thank
That
you.
makes sense. Okay. That was a really ugly box and whisker plot, though. Yours better not look that ugly. I'll give you all a moment. Okay. You need another moment? Are we good? Okay, let's move on then. Okay. We're not going to construct this box and whisker plot. You're going to see one. It's nice and pretty. And we are going to draw one in a second. But every 6 months, the United States Federal Reserve conducts a survey of credit card plans. They look at the interest rates charged by credit card issuers. That's this right here. We're going to make a box and whisker plot. So here we go. So take a look here. So my lower fence is right here at about 8.4%. It's right there. I'm going to redraw that on there so you can see it. My upper one is at 18% right here. Notice how my whiskers do not go all the way to the fences. They go to the last data value that is still inside the fence. Well, I mean, it's kind of like if I'm checking on my cows out in the field, I'm not going to walk all the way to the fence to check on the cows. I'm going to go to the last cow that is still inside the fence. Then I'm going to get in my truck and go get the ones outside the fence. But you don't have to go all the way to the fence. You just go to the last one that's still inside the fence. This asterisk right here is an outlier. It is outside my fence. It is an unusual value. So that's the cow that I have to take my truck out and go get. Don't ask where that came from. I just fences cows. It just happens. So this is one that's already done for you. We are going to do one together. So I'm hoping you have a nice open piece of paper and we're going to draw one together. Okay. Anyone need a moment? Are we good? All right. So we're going to use the 5-number summary from our collision loss data to create a box and whisker plot. And I would love it if you would draw this with me, but maybe give me a little lead time because I'm going to do some strange things. And the only way that I know the scale to do this one at is because I've done this a lot. So I'm going to start way down here and I'm going to draw this line. It's going to have to be extended in a minute. But I'm going to start at 0 and I'm going up by 500, but I'm only going to label by 1,000. So it's 1,000, 2,000, 3,000, tell you, I had to draw this a lot of times and label it wrong in order to get to the right label. There didn't need enough zeros. Okay. Okay, I know that our data goes all the way up to 21,147, but there's going to be a lot of blank space between 11,000 and 21,147. So we have this little trick. We can put a break in our graph. So we just kind of put the squiggles here. This is just saying I ripped part of my graph off, the part that I don't need, and now I can start over. And I'm going to start right here. So I'm going to do this is going to be 21,000. And then there we go. So what I did was I just put a break in my graph. So basically I cut out a big chunk, about 10,000 in my graph, because can you imagine how long that would have to be? I'd have to make my scale something different. So I just put a break in the graph. And this is completely allowed. This is not illegal in the land of statistics. It's completely allowed. Feel free to do it if you need to. Just make sure that you put some sort of a squiggle that looks like a break. All right. Next, we are going to put vertical lines. So notice, before I do this, notice this is a complete underline, a complete number line underneath of it. Even though I don't need all of those numbers, we are not just targeting the numbers we know. We're just making sure that the full range of the number line can contain our data. So my median is 1805. So I'm going to put a vertical line right there at my median. So it's just an approximate. My Q1 is 735. So that is probably about right here. Might be a little bit lower than that, but we're going to pretend. And then my Q3 is 4668. So it's right about here. And then you enclose these in a box. Just like that. I know that it said to label your fences first, but I don't do that. I do the box first, just kind of because it's fun. All right. After we have the box, now we're going to label our fences. And because I am me, I'm going to change my color. So my lower fence is at negative 5164.5. Clearly that's on my number line. So normally I would make sure that the number for my lower fence is on my number line, but this number is so completely ridiculous that I usually just will put it off here and I will label what it is, negative 5164.50. Because it does not make sense to extend the number line super far. I mean, if you want to, you could put a little break in there and then draw it like I did on the right side, or you can just do something like this. This is acceptable because it's just a completely ridiculous lower fence. The upper fence is kind of more important though. Our upper fence is 10,567 and change. So my upper fence is about here-ish. That one's going to be important. Yeah, I know it's smaller than the other. I hope that doesn't annoy you. All right, let's talk about whiskers. Make sure you stop me if you have any questions as we're going. So my whisker, my lowest value inside my lower fence is 180. So I need to make my lower fence go to about 180. I'm going to guess where that is. So it's going to go, or my lower whisker. So approximately right there. So it does not go all the way to the fence. It just goes to the last value inside the fence. And the top, my last value inside the fence is 10,034. So it's going to go all the way up here. It's going to get pretty close to the fence, but it is not going to touch my fence. So it's about right there. That is my upper whisker. So finally, the last piece is my outlier. The outlier is 21,147. So it is approximately right there. So just put an asterisk. And that's it. That is our beautiful box plot.
So I'm so confused.
Okay, where did I lose you?
The 5 numbers would be the green line right before the 0. Right?
This one right here. Yeah, because this right here is my lower. So this right here, don't write this in here. This is not part of the box and whisker plot. It's 180 right there.
And then the top green part is my last number
Okay.
of
This,
the
one-
5 numbers, right?
this one,
Yeah.
well, yeah, it's the second to last. But this is not part of your 5-number summary. This is the last value inside the fence. This
So
one here is
how do I get that again?
this was just the last value. So if you look at your data, so and I can, if I look at my data, it's way back here. Hold on a second here. Hope I don't give anybody a headache or anything. So if you look at your data right here, once we determined where our fence was, it should get there. Once we determined where our fence was, we determined our fence was 10,000. What is it? 567.5. That's my fence. I just looked at my data and I saw that this is the last value before my fence.
Where did you get 10,567?
This is the one we calculated using the one
Oh,
IQR.
okay. It's because I didn't print the slide, so I'm a little confused. So the last whisker is always the second to last number.
Well, unless if my whisker, if my fence was higher than this number, then the whisker would be to that number.
Okay,
Because that's an outlier that he lives outside the whisker. That's that cow that escaped. He has to be an asterisk on the outside.
okay.
Does that help?
Yeah,
Okay, good.
thank you.
You're welcome. I'm sure that there was somebody else that had the exact same question, or someone watching this video will have that exact same question. So thank you for asking, for not being shy. I appreciate it.
Melissa,
Yes.
couldn't you just deduct any absurdly different value would just naturally become an outlier or that away from the data?
You're kind of breaking up. I can't, can you try saying it again? Oh, I just lost something. Go ahead.
Could you assume that any value you get is an outlier if it's that far outside of your data set?
I mean, yes, but we still want to actually have the math. I don't know why this is not working. We still want to have the math because I mean, you still need to find out where that fence lives. But sometimes there are outliers that like you visually can tell that that's an outlier, but sometimes they're barely an outlier. I'm going to try unplugging this and plugging it back in again. See if that helps. So I mean, like this one is an obvious outlier, but okay, there we go. But let's say, what if I had a data value that was at 10,600? That is not so obviously an outlier, but my fence is at 10,567. So it wouldn't be quite as obvious. Like this one, I probably could have told you, you can look at it and be like, yeah, that one is extreme. So sometimes they're extreme and you're going to notice it, but we still need to find our fences. We still need to know what this is right here. Because there are times there are 2 outliers. It happens. There could be 2 asterisks outside. Did that help? Okay. All right. Any other questions about the box and whisker plot? Did drawing it with me help? Was that helpful? Okay. Good. So we have one final slide and then we will get to the lab. The lab is super fast. Here we go. So as you could tell by looking at this, we are skewed right because my right whisker is so much longer than my left whisker. You can see that our data is skewed right. So take a look at the visual here. You can see the box plots compared to the histograms, and you can tell that the skew, and this is, I just like the visual to be able to kind of compare in a histogram to a box plot. You can kind of see where the skew is, how it's skewed right and skewed left or symmetric. So that's it for the lesson portion. It clicked, yay. Okay, so that's it for the lesson portion, and we'll get ready to do the lab in a second. And doing the lab is going to be kind of awkward and tricky because I need to show two different ways to get the data analysis tool depending on what type of computer you have or which version of Excel you have. So I'm going to have to pop over to my other computer and all that, but I want to make sure you can get that tool. Any other questions before we move on? Okay. I'm going to put my iPad down. All right. So with the different versions of Excel, we're going to before I do this, I need to preface this by saying the tool that we are going to be getting is not available on Numbers, as far as I know. It is not available in Google Sheets. I actually think that it is a paid extension in Google Sheets, because when I was looking for it for my AP Stats class at the high school, the only place I could find it was a paid extension, and ain't nobody got time for that. We do not want to be paying for anything. So on Excel, this is one that you definitely have to use Excel for. So the tool, I'm going to show you how to use it. The computer we're on right now is my school issued Mac. It has, I don't know which version of Excel it is, but it has different tools than my PC. So I'm going to show you on the Mac first, and then we will take a look at the PC. So the tool that we need is called the data analysis tool. So on your Excel, so I put my data over here. On your Excel, you'll click on data. And if it looks like this, where it just says analysis tools over here, you're going to need to add an extra tool to it. So in order to do that on this version of Excel, you just click on analysis tools right here. And then you need the analysis tool pack. So you'll just check the box that says analysis tool pack. And I'm going to click OK. And now data analysis tool pops up. So once again, you click on data, which is right up here at the top. Click on analysis tools, and you want analysis tool pack checked. Now, if this is not your version of Excel, I need to change this so that I can share parts, so that I can share with my other computer. Okay. So give me a second. I'm going to unshare. I'm going to stop my share and go over here, share my screen. All I want is Excel. Okay. Share my screen. Okay, let's get this. All right. So on this version of Excel, it's not showing yet. Give it a second. There we go. On this version of Excel has file up at the top left. I need to move some things. There's file up at the top left. When I click on data, there's a big empty square. Move this. There's just an empty square right here on the far right. So I don't have a data analysis tool. So let me show you. This is the more common version of Excel right here. Let me show this to you. So you click on File, and then go all the way down to the bottom to Options. And this menu pops up. You want add-ins. Add-ins is right here. And you're going to go down to the bottom to Manage Excel Add-ins, because it's going to show add-ins. I think there's other things, but we just want Excel add-ins, and click Go. You want the top two, Analysis Tool Pack and Analysis Tool Pack VBA. So once you check those two boxes and then click OK, and then the data analysis tool will show up. I'm going to show you one more time. You click on File, all the way down to Options. Then go down to Add-ins and Manage Excel Add-ins. Click Go. And then you want the top two choices. And you click OK, and that'll give you your data analysis tool. All right, I'm going to stop sharing here. And I'm going to go back to my other screen because this one is better for this. Okay. Okay, let us do some learning. Okay, So now that we have our data analysis tool, I have all of my continuous data right here. This is the earthquake magnitude stuff that I used before. So before you even highlight your data, you're going to click the data analysis tool right here. And you're going to scroll down or scroll up, whichever way. I would like descriptive statistics. That's what we're looking for. Click on data analysis and you want descriptive statistics. Click OK. I think it even says, yeah, it says place descriptive statistics in this box. So my input range is going to be all of these things right here. So I'm just going to highlight them. And I'm going to highlight them all the way down. So let's say that I'm too lazy and I don't want to highlight all of them. I'm only going to go to 120, but I know it goes to 140. I can change this number here to make it go to 140. You can change any of those numbers once you do that, because this is just your input range. Then you're going to click on output range. My output range, where I want it to land, is in this box up here. So I'm just going to highlight the boxes that I like. Just going to highlight those. And that's going to give me where I want it to land when it gives me all of my stuff. Over here, check the box that says summary statistics. Check that box and then click OK. And I get all sorts of cool stuff. I'm going to widen this so we can see it. I get all sorts of cool stuff. I'm going to make this bigger so you can see what we have here. And the really cool thing about this is you get everything all at once. You do not have to individually calculate all of these things. It gives you all sorts of super important information. So this gives me my mean. So we'll deal with standard error later. Don't even look at that. I have my median, the mode. Here's the standard deviation. Don't worry about variance or kurtosis or skewness. I have my range, the minimum, the maximum. If I wanted them all added together, I have that. If I want to know how many there are, it tells me that. We'll be using more of these options later on. One of our other labs uses this tool again. Okay, so here is what I want you to have Excel do almost all of the work for you. I don't want you typing things in this box other than commands, because basically what we're learning here is how to make Excel do things for you. So I don't want you typing the mean in this box, because the purpose is to learn how to do have Excel do it for you. So whenever we're trying to command Excel to put something in a box, we always start off with equals. I'm going to click in the mean box and I'm going to say equals. I want the output here to equal what is in this box over here. So if I click on this box, it's going to put that number in the box. Same thing with standard deviation. I'm going to put equals, and I want it to be this standard deviation right here, and hit enter. So it's going to just populate those for you. We're going to go back to number 2 because we're going to do all of the Excel stuff first, and we're going to go back to number 2. So we'll just put a pin in number 2. For the median, once again, we're going to click equals, and then we're going to click over here on median. Yes, I know you can type the number 7 in there, but we're just learning how to do Excel tools. Equals, mode is 6.3 right there. Number 4, I am going to talk about this. I do not want you to use this kurtosis or skewness right here. What I want you to do is to go back to previous lesson and to compare your mean and your median. So for example, my mean and my median are almost the same number. Because they are super close, my data is not skewed. It is roughly symmetric. And I want you to think about what it means if your mean is bigger than your median or your median is bigger than your mean. And I want you to type that in here. I want you to say, my mean is larger than my mean, therefore, here's the skew of my data. That's what I want you to type in that box. All right. So 5 numbers.
I'm sorry.
Go ahead.
That would be left skewed or right skewed.
Right, yes. But I want you to reference my mean is bigger than my median, or my median is bigger than my mean. That's what I'm wanting in box 4. I just want you to look at those and to think back to previous lessons and what we learned about that.
Okay, thank you.
So my lower value, once again, it equals minimum right here. What this doesn't give me is Q1, but I have a fun calculator. I have a fun Excel tool that will give me my Q1. So I'm going to click equals and type in the word quartile. And it doesn't matter if we're quartile included or excluded, it doesn't matter. So what this tells you is array and quartile. So the array is, I want the quartile of all of my numbers. I want the quartiles of all of these numbers. Okay, I'm gonna highlight them. You're not gonna have 140 data values, so it's gonna be much easier for you. That's my array, comma, 1 for first quartile. Because we want quartile 1, so you put 1. So what you do is you say quartile, highlight all your data, comma, 1, and hit enter, and it will give you your quartile 1. Quartile 2, of course, is your median, so just equal median, enter. So what I'm going to do for quartile 3 is I'm going to be really lazy here. So I don't want to highlight all my data again. So what I'm going to do is I'm going to copy and I'm going to paste. Now you don't have to do this, but it's just me being lazy. Paste that in there and then go up to the top here and change this to quartile 3 and hit enter. Now you can just type it in if you want, but I'm being lazy. The high is my maximum equals maximum, enter. All right. The final thing that Excel is going to do for us is give us our interquartile range. Excel can do so many things. It does tons of math for us. All we're going to do here, though, is subtract. So watch this. I'm going to do equals quartile 3. So click on this box, minus, then click on this box and hit enter, and it's going to do that math for you. So I want you to have it do as much of the math as possible. So because this is the purpose of this. So when you're doing your final project or when you're at some job someday where you need to use some spreadsheet tools, I want you to be able to use your spreadsheet tools to create all of this stuff. I have done a lot of things where I'm crunching data and I have Excel do all of this really great work for me. And then I can just interpret based on what it says. It's really kind of cool. Okay, so let's go back to number 2. So this asks me if I have any unusual data, and we are referring to z-scores. Remember, z-scores use the mean, and any z-score bigger than 2 or less than -2 will be an outlier. So you need to somehow determine using z-scores where your outliers are. There's 2 different ways to do this. I can grab my bottom value and my top values, and I could find out their z-scores and say, hey, the z-score of my lowest value is -2.3, therefore it's an outlier. Or you can figure out where those upper and lower limits are. You can figure out what 2 standard deviations away from your mean is above and what 2 standard deviations away from your mean is below. You can use that 2 standard deviation rule, and then any values above the top or below the lower would be outliers. So somehow using z-score and standard deviation, you need to determine if you have any outliers. And this is the place where you're telling me about them. You don't have to show me the math, but you can tell me the z-score of this one is 2.3, therefore it's an outlier. Something like that. That's it. That is all this lab is. Any questions?
Is there only one tab of work or is it a multi-tab situation?
It is a 1 tab of work.
Right on.
Do you have to calculate the lower and upper z-score?
Well, you're going to want to see if you have any. So I would probably figure out, I think the better way to do it would be to find out what the lower bound is and what the upper bound is. So I could do something like this. So take a look here. So I could say equals the mean plus 2 times standard deviation. I'm just whoops, what did I do? I typoed somewhere. Okay, and this calculated my upper limit. I'm just, you don't have to do it this way. And then I could say lower limit, and I could say, mean equals mean minus 2 times standard deviation. It says I have a typo again, and then I have my upper and lower limits right there. And then I could just compare it to my data. You don't have to do it this way, but if you want to do it this way, that works. So basically you just say equals, and then you just have it do math for you. You don't have to do this. You can even calculate it on your own fancy schmancy calculator and put it in there however you want to. But this to me is more efficient than checking values. Is find that upper limit, find the lower limit, and then say, this one is below my lower limit, therefore it is an outlier. Does that help? Okay. Anyone else? Okay, I'm going to stop the recording, and then if we have any questions after that, we can do that.